Today we are going to understand a problem on solar PV system. Okay, already you studied how to connect the solar panels in series connection and how to connect the solar panels in parallel connection. Now we are going to see a problem on how to connect the solar panel in series connection as well as in parallel connection, that is called as NS. Identify the number of panels in series connection, identify the number of panels in parallel connection is the problem given, and the power rating of the plant is 10 kilowatt and the output array voltage is 200 volts, output current is 50 amperes. This is the data given in the problem. So now we want to design a 10 kilowatt plant with modified values of finding NS and NP, and this solar panel, each panel is having the maximum voltage of 35 volts and maximum current of 8.5 amperes. Now we need to identify the number of panels in series connection. So already we know that the maximum voltage of the array is equal to number of panels connected in series connection multiplied with the maximum voltage of the individual panel. So then we can find out the number of panels which are connected in series connection. So what is VMA given in the problem? 200 volts divided by, what is the VM given in the problem? Each panel is how much rated? 35 volts. Try to find NS value. Number of panels in series connection is equal to 200 by 35. 5.71, which is equal to the number of panels which are connected in series is equal to, how many are there? 6 panels are connected in series. Now we got one answer. The number of panels connected in series is 6 panels. Next one, we are going to find out the maximum current developed by the array is equal to number of panels connected in parallel multiplied with what? The individual current IM. The individual current IM. So IM is already given in the problem. What is the current? 50 amperes. So 50 amperes divided by, what is the value of IM given in the problem? 8.5 amperes. Automatically ampere will get cancelled out and you are going to get the number of panels to be connected in parallel. Okay, so try to do it with your calculator and say this value. 5 point, louder, 5.8. So we are going to make it round and we are going to call the number of panels to be connected in parallel is how many panels? 6 number of panels we need to connect in parallel. Okay, now we need to find out whether this is delivering the required power of 100 or not. Okay, so the maximum power of the array is equal to the maximum voltage of the array multiplied with the maximum current of the array. So already we know that VMA, we can write down it as NS. What is the value of NS now? So it is nothing but NS into VM and this is the product of NP into IM. So already we know the value of NS. Already 5.71 we are done, but we round figured it to 6. Why we round figured? We generally don't have the panels, 5 panels, 71, 0.71 panels. Okay, that's why we round figure to 6. Okay, whatever the figure you got after the decimal, we'll try to round for the upper value. Okay, therefore NS value is 6 and what is the voltage rating of the panel? 35 volts. And coming to here, how many panels we need to connect in parallel? 6. 6 into, what is the current? 8.5 amperes. We try to scale up all these 3 quantities and say the value. So NS is how much? 6. Okay, directly is there. How much is the product is? 6 into. So 6 into and this is also 6 into. 10710 watts, but actually we generally specify the plant in what? Kilowatt. So how to convert this watts into kilowatt? Multiply with 1000 divided with 1000. So when you do this, how many decibels will come? 1 decibel will come. Then I am going to get 10.71. So I divided and this 1000 I am going to write it as kilowatt, where this is the maximum volt per maximum power generated by the array. Now we designed what is the rating of the plant? 10 kilowatt or 10.71 kilowatt plant we designed. Yes or no? So what is asked is design a plant P of, he already told some 10 kilowatt, but after retuning the maximum power of the array is how much? 10.7 watts. So this is how to, now we want to draw the diagram for this. Okay, now we need to draw the diagram of connecting the panels in. Just remember how many panels are there in series now. So from, I think it's clear now how many are in series and how many are in parallel. Let's try to write down directly, we'll try to draw the diagram. Now how many panels are there in series connection? 6 panels. And how many panels are there in parallel? 6 number of panels are there in parallel. Now we need to draw the diagram. Okay. So now I am going to construct the solar array. Okay. So now let's try to construct series construction. Okay. So this is one solar panel. This is second solar panel. This is third solar panel. 4, 5, 6. Okay. So I am giving the labeling 1, 2, 3, 4, 5, 6. And these 6 panels are connected in what? Which connection? Series connection. Okay. So series means you will have one positive, negative, one positive, one negative, one positive, one negative, one positive, one negative. So like this you are going to have the terminals. So now what you can do, you can join, this is positive, negative, positive, negative, positive, negative, positive, negative, positive, negative, positive, negative. Now we join the negative to the negative terminal of first panel to positive terminal of the second panel, the negative terminal of one terminal to positive terminal of the next panel, the negative to positive, negative to positive, negative to positive, and you are going to get the resultant. Now all these 6 panels are connected in which connection? Series connection. So when they are connected in series connection, automatically what will happen? The voltage gets added up. What is the resultant voltage? 35 volts into 6. Perform it. What is the value of VMA? So VMA is equal to 6 panels multiplied with 35 volts. This is how much? 210 volts. So now it is going to generate how much voltage? 210 volts. So the voltage at this point is 210 volts. The voltage at this point is 0 volts. So this will constitute, this is called as which one? This is called as what? Panels are connected in series. This will constitute what? Completely will constitute an array. Let's try to take, this is one string. Okay. So this will constitute string 1. And the complete we are going to call it as an array. Okay. So this will constitute string 1. Now similarly we want to construct what? String 2. So generally I am forgetting the symbol. You can see that defaultly the symbol is like this. So when you draw it neatly. Okay. So next one I am going to construct the second string like this. 1, 2. So join them. And resultantly you are going to get a connection and join here, and this resultant you are going to join here. Okay, what is the voltage at this? All are connected in series. What is the voltage? 210 volts. Okay, so can you say the numbering? 7, 8, 9, 10, 11, 12. So similarly next you are going to get how much? 13 to 18. Next one 19 to 24. This is nothing but string 3. Next one string 4. Next one what are you going to get? String 5. So this 19 to where? 24. Next one 25 to 30. So sixth string you are going to get from, so 31, 32, 33, 34, 35, 36. Okay, so this is 31, 32, 33, 34, 35, 36. So in between you draw the shape. Okay, so how they are connected? Positive to negative, positive to negative, positive to negative, positive to negative, positive to negative. What is the resultant terminal you are going to get here? Positive. What is the resultant terminal you are going to get here? Negative. Okay, so now So here you will have one junction point with respect to this one, and here you are going to have one junction point, and at this 25 also you are going to have one junction point, and at 31 also you will have one junction point. So similarly also here you will have one junction point with this, and with this one more junction point, and with this one more junction point. Okay, you see here what is the voltage that will be generated by the series panel? How much? 210 volts. And I can see here 6 solar panels are connected in series connection. In second row also how they are connected? Series connection. 13 to 18 number panel also connected in series connection. Like that, how many series connections are there? 6 are connected in series. Like that, how many parallel we require? 6 parallel. So string 1, string 2, string 3, string 4, string 5, string 6 are connected in parallel. When they are connected in parallel, what is constant? Voltage is constant. But what is going to add? Current is going to add. I am assuming that the current in an series connection, what is constant? Current is constant. What is the amount of current here? The current in this branch is how much? 8.5 amperes, and the current also is coming from the second string as 8.5 amperes. The resultant current is what? The sum of these two currents. Add it. 8.5 plus 8.5. 17 amperes. So 17 amperes is coming from the two strings, and the third string is also injecting a current of how much? 8.5 amperes. Now you add 17 plus 8.5 by applying how much? 25.5 amperes by applying KVL. Okay, and this third string is also generating a current of how much? 8.5. You add 12.5 plus 8.5. 34 amperes, and this string is also adding a current of how much? 8.5 amperes. The resultant current, I mean this current you want. Okay, so the resultant current is entering current is 30 amperes, and one more entering current is 8.5. 34 plus 8.5, how much? 42.5 amperes. And from this also how much is entering? 8.5 amperes. Okay, so the resultant current entering into the output of the panel is how much? 42.5 plus 51 amperes. Okay, so this is nothing but IMA. So you may get doubt whether it is correct or not, whether we have done correctly or not. Exactly, we have done correctly. So if you want a doubt, so IMA is equal to how much? NP into IM. What is NP? Number of panels. How many panels are there? 6 panels. And what is the current of individual? 8.5. Multiply this one. 51. So here also you got as the same. So now we constructed string 1, 6 panels connected in series, string 2, 6 panels connected in series, string 3, 6 panels connected in series, string 4, string 5, string 6. All 6 strings are connected in which connection first? Series. When they are connected in series, the voltage gets a product of 6 times, then you are going to get 210. So I can see here, this is node 1, I mean junction 1, junction 2, junction 3, junction 4, junction 5. So totally from here you are going to get one more junction. 6 junctions are there. All these 6 strings are connected to the common point. Automatically the resultant current is multiplied, or it is added with 8.5 into 6. You are going to get the current of 51. Now already you know the formula. The maximum power of the array is equal to, already we have done it, maximum voltage of the array multiplied with the maximum current of the array. What is the maximum voltage of the array? From the problem we are getting, after drawing the diagram, 210 volts multiplied with what is the maximum current? 51 amperes. You multiply it, how much you got? 10,710 kilowatts. So this is the rating of the solar power plant as per the given problem, how to connect them in series connection as well as in parallel connection.